Hello students, today we start next example on derivative of parametric function. Find dy by dx if x equal to 2 cos t plus cos 2t and y equal to 2 sin t minus sin 2t. At t equal to 5 by 4. Solution: x equal to 2 cos t plus cos 2t. Differentiate with respect to t. Therefore, dx by dt equal to 2 into d by dt of cos t plus d by dt of cos 2t equal to 2 into d by dt of cos t minus sin t plus d by dt of cos 2t minus sin 2t into d by dt of 2t equal to minus 2 sin t minus sin 2t into 2 into 1 equal to minus 2 sin t minus 2 sin 2t. 2 common, minus 2 common, sin t plus 2 sin 2t. This is the value of dx by dt. Now consider y equal to 2 sin t minus sin 2t. तो ये तुम्हें सोडो. Solution: differentiate with respect to t. Therefore, dy by dt equal to 2 into d by dt of sin t minus d by dt of sin 2t equal to 2 into d by dt of sin t cos t minus d by dt of sin 2t cos 2t into d by dt of 2t equal to 2 cos t minus cos 2t into d by dt of 2t 2 into 1. Take 2 common, 2 into bracket cos t minus cos 2t. This is value of dy by dt. Now from these two values dx by dt and dy by dt, we find the value of dy by dx. dy by dx equal to dy by dt upon dx by dt equal to dy by dt 2 into bracket cos t minus cos 2t dx by dt minus 2 into bracket sin t to common sin t plus sin 2t 2 to cancel equal to cos t minus cos 2t upon minus into bracket sin t plus sin 2t. Now we have to find dy by dx at t equal to pi by 4. Therefore dy by dx at t equal to pi by 4 equal to, put t equal to pi by 4, cos pi by 4 minus cos of 2 into pi by 4 pi by 2 upon minus sin pi by 4 plus sin of 2 into pi by 4 pi by 2 equal to final answer is cos pi by 4 1 upon root 2, cos pi by 2 0, sin pi by 4 1 upon root 2, sin pi by 2 1 equal to 1 upon minus root 2 into bracket 1 upon root 2 plus 1 multiply by root 2. Therefore minus 1 upon root 2 into 1 1 by root 2 1 plus root 2. This is the answer. Now second example. Find dy by dx if x equal to t plus 2 sin pi t and y equal to 3t minus cos pi t at t equal to 1 upon 2. Solution. Try to solve this problem. x equal to t plus 2 sine of pi t. Differentiate with respect to t. Differentiate with respect to t. Therefore dx by dt equal to d by dt of t plus 2 into d by dt of sin pi t equal to d by dt of t 1 plus 2 into d by dt of sin pi t cos pi t into d by dt of pi t equal to 1 plus 2 into cos of pi t into d by dt of pi t, pi constant coefficient into d by dt of t equal to 1 plus 2 pi cos of pi t into 1 d by dt of t 1. Then dx by dt. Now we find dy by dt from y equal to 3t minus cos of pi t. Y equal to 3t minus cos of pi t. Differentiate with respect to t. Differentiate with respect to t. Therefore difference with respect to t. Therefore dy by dt equal to 3 into d by dt of t minus d by dt of cos of pi t equal to 3 into d by dt of t 1 minus d by dt of cos pi t minus sin of pi t minus sin of pi t into d by dt of pi t d by dt of pi t equal to 3 minus into minus plus sin pi t into d by dt of pi t pi into 1 equal to 3 plus pi sin pi t. This is the value of dy by dt. Now from these two values we find dy by dx at t equal to 1 by 2. dy by dx equal to dy by dt upon dx by dt equal to dy by dt 3 plus pi sin pi t. So what is the value of dx by dt? Write the value of dx by dt in the denominator and then put dy by dx at t equal to 1 by 2 and find the value of dy by dx. This is homework for you. Next example. find dy by dx if x equal to t square plus t plus 1, y equal to sin of pi t upon 2 plus cos of pi t upon 2 at t equal to 1. So now try to solve this problem by pausing video. Now solution is, first we write x equal to t square plus t plus 1. T square plus t plus 1. Differentiate with respect to t. Therefore dx by dt equal to d by dt of t square plus t plus 1. T square plus t plus 1 equal to, now use addition rule in this example. Use addition rule. D by dt of t square plus d by dt of t plus d by dt of 1 equal to 2t plus 1 plus 0 equal to 2t plus 1. This is the value of dy by dx by dt. Now we find the value of dy by dt from this equation. Y equal to sin of pi t upon 2 plus cos of pi t upon 2. Differentiate with respect to t. Therefore dy by dt equal to, addition rule operator, d by dt of sin of pi t upon 2 plus d by dt of cos of pi t upon 2 equal to d by dt of sin of pi t, derivative of sin x cos x, derivative of sin of pi t upon 2 cos of pi t upon 2 into d by dt of pi t upon 2 plus d by dt of cos of pi t upon 2, derivative of cos x minus sin x minus sin of pi t upon 2 into d by dt of pi t upon 2 equal to d by dt of pi t upon 2 pi by 2 into 1 pi by 2 into cos of pi t upon 2 minus d by dt of pi t upon 2 pi by 2 into 1 pi by 2 sin of pi t upon 2. Now this is value of dy by dt and this is value of dx by dt. From these two values we find the value of dy by dx at t equal to 1. Therefore dy by dx equal to dy by dt upon dx by dt equal to dy by dt pi by 2 into cos of pi t upon 2 pi by 2 into cos of pi t upon 2 minus pi by 2 into sin of pi t upon 2 dx by dt This is the value of dx by dt. 2t plus 1. 2t plus 1. Take pi by 2 common and put t equal to 1. Therefore, dy by dx at t equal to 1 equal to pi by 2 into cos of pi by 2 into 1 pi by 2 minus pi by 2 into sin of pi by 2 into 1 pi by 2 upon 2 into 1 plus 1 equal to cos pi by 2 0 pi by 2 into 0 minus pi by 2 into sin pi by 2 1 upon 2 plus 1 3. Now after simplification we get 0 minus pi by 2 upon 3 equal to minus pi by 6. Minus pi by 6. Pause video and write down this solved example in your notebook. Next example. Last example. Find dy by dx if x equal to sec square theta, y equal to tan cube theta, at theta equal to pi by 3. At theta equal to pi by 3. Second example. X equal to t plus 1 upon t, y equal to 1 upon t square at t equal to 1 by 2. Third example. X equal to 3 cos t minus 2 cos cube t, y equal to 3 sin t minus 2 sin cube t, 2 sin cube t at t equal to pi by 6. So out of these 3 examples we take only one example. Example 3. X equal to 3 cos t minus 2 cos cube t. Differentiate with respect to t. Therefore, dx by dt equal to 3 into d by dt of cos t minus 2 into d by dt of cos cube t equal to 3 into d by dt of cos t minus sin t minus 2 into d by dt of dy by dt of cos t bracket t. सर्व इथून पुढे therefore dx by dt equal to minus 3 sin t minus 2 into d by dt of cos t raised to 3 formula parameter x raised to n चा 3 into x raised to 3 minus 1 3 into cos t raised to 2 into d by dt of cos t equal to minus 3 sin t minus 2 into 3 d by dt of cos t minus sin t cos square t into minus sin t. Take 3 common minus 3 take 3 common 3 into bracket minus sin t minus into minus plus cos square t. Take minus take sin t also common equal to 3 into sin t common 3 into sin t common पुन्हा 3 sin t common into bracket minus 1 plus minus into minus plus 2 cos square t equal to 3 sin t into formula operator 2 cos square t minus 1 2 cos square t minus 1 equal to cos 2t. This is the value of dx by dt. Y equal to 3 sin t minus 2 sin cube t. Y equal to 3 sin t minus 2 sin cube t. Differentiate with respect to t. Therefore dy by dt equal to 3 into d by dt of sin t minus 2 into d by dt of sin cube t in the sin t bracket cube equal to 3 into derivative of sin t cos t minus 2 into derivative of sin t bracket cube 3 into sin t raised to 3 minus 1 into d by dt of sin t equal to 3 cos t minus 2 into 3 into sin t raised to 2 sin square t into d by dt of sin t cos t. Take 3 cos t common 3 cos t into bracket 1 minus 2 sin square t. Use formula of 1 minus 2 sin square t. 1 minus 2 sin square theta equal to cos 2 theta. 1 minus 2 sin square t cos 2t. Now from these two values we find dy by dx. Therefore dy by dx equal to dy by dt upon dx by dt equal to dy by dt 3 cos t into cos 2t, 3 cos t into cos 2t, dx by dt 3 sin t into cos 2t, 3 sin t into cos 2t, cos 2t cancel, 3 cancel, therefore dy by dx equal to cos t upon sin t cot t. Now therefore dy by dx at t equal to pi by 6, t equal to pi by 6 equal to cot pi by 6 equal to cot 30 equal to cot 30 equal to tan 30 1 upon root 3 cot 30 root 3. उरलेले दोन एक्झाम्पल घरी सोडा.